Does consciousness create reality? Quantum decoherence, the physical process operating for 13.8 billion years, proves it doesn't. The universe was already decided before consciousness existed, and the evidence for this is not philosophical speculation, but measured, confirmed, mainstream physics. Quantum decoherence, the process by which environmental interactions destroy quantum superpositions and enforce definite classical outcomes, operated continuously for 13.8 billion years before any conscious observer appeared. The measurement problem, the question of how a quantum system's probabilistic wave function yields a single definite result, was resolved by the environment, not by the mind. Even Schrödinger's cat thought experiment, the famous paradox of quantum superposition, is solved by decoherence. The cat decoheres in unmeasurably short time, always alive or dead, never both. The cosmic microwave background radiation, the thermal relic of the early universe, emitted approximately 380,000 years after the Big Bang at a temperature of approximately 3000 Kelvin and measured today at 2.725 Kelvin, was released through physical processes alone, in a cosmos devoid of any biological life, any nervous system, any awareness of any kind. The fine-tuning of the physical constants, the fine structure constant at approximately 1/137, the strong nuclear force coupling calibrated to within 2% of the value that permits stable hydrogen, the cosmological constant at approximately 10 to the negative 122 in Planck units, was established in the first moments of the Big Bang, billions of years before the first neuron fired. And the anthropic principle, the observation that the universe appears fine-tuned for the existence of observers, does not mean the universe required observers to become real. It means the universe was configured from the beginning with a precision so extraordinary that conscious beings could eventually exist to notice it. The question is not whether the universe was decided before consciousness. The physics is conclusive. It was. The question is, who decided it? What follows is a forensic examination of the evidence. By the end of this video, you will understand quantum decoherence, the physical process that enforces classical outcomes without any role for consciousness. You will understand why the consciousness creates reality claim, the von Neumann-Wigner interpretation of 1961, biocentrism, New Age quantum mysticism, is contradicted by mainstream physics, abandoned by its own originator, and rejected by every major interpretation of quantum mechanics. You will understand the timeline. 13.8 billion years of cosmic history, primordial nucleosynthesis, recombination, the formation of the first stars, the assembly of galaxies, the forging of heavy elements in supernovae, the formation of the Earth and the Sun, all of it decided by physical processes and quantum decoherence, without a single conscious observer. You will understand the interpretations of quantum mechanics, Copenhagen, many worlds, Bohmian mechanics or pilot wave theory, objective collapse, and why none of them requires consciousness. You will understand the fine-tuning evidence, acknowledged by secular physicists from Stephen Hawking to Paul Davies, and why the multiverse is not an explanation, but an escape route. And you will understand why the evidence, when examined honestly, points not to consciousness creating reality, but to an intelligent, powerful, eternal creator who configured reality before consciousness arrived to witness it. If this channel is the kind of content you return to, consider subscribing. There is no algorithm shortcut for depth. Let us examine the evidence. First, the timeline evidence. The timeline is the foundation of the argument, and the timeline is not in dispute. The universe began approximately 13.8 billion years ago. This age is confirmed by multiple independent measurements. The cosmic microwave background data from the Planck satellite, ESA 2009 to 2013, final data released 2018, which determined the age at 13.80 plus or minus 0.02 billion years. The Wilkinson Microwave Anisotropy Probe, WMAP, NASA 2001 to 2010, which measured 13.77 plus or minus 0.06 billion years, and independent estimates from the Hubble constant and the expansion rate. The Planck satellite measured the Hubble constant at h sub 0 equals 67.4 plus or minus 0.5 kilometers per second per megaparsec, approximately 41.9 miles per second per megaparsec. 1 megaparsec is approximately 3.26 million light-years. The expansion rate, combined with the measured matter and energy content, yields a consistent age of approximately 13.8 billion years. At 1 second after the Big Bang, the temperature was approximately 10 billion degrees Celsius, approximately 18 billion degrees Fahrenheit. Within the first few minutes, protons and neutrons fused into helium nuclei, primordial nucleosynthesis, establishing the hydrogen-to-helium ratio that persists today. Approximately 75% hydrogen, 25% helium by mass. This ratio is measured in the spectra of distant quasars and in the composition of old metal-poor stars. It matches the predictions of Big Bang nucleosynthesis precisely. At approximately 380,000 years after the Big Bang, the universe cooled to approximately 3,000 Kelvin, approximately 4,940 degrees Fahrenheit, and electrons combined with nuclei to form neutral atoms. This is recombination. Before this moment, the universe was opaque. Photons scattered continuously off free electrons, unable to travel far. After recombination, the universe became transparent. The photons released at that moment, the cosmic microwave background, have been traveling through expanding space ever since, cooling from 3000 Kelvin to 2.725 Kelvin as the universe expanded by a factor of approximately 1,100. No conscious observer witnessed recombination. No mind collapsed the wave functions of the atoms that formed. No consciousness directed the photons of the CMB as they decoupled from matter. These were physical processes governed by quantum electrodynamics, statistical mechanics, and general relativity that occurred in a universe devoid of biological life. The photons had definite energies. The atoms had definite states. The density fluctuations, approximately 1 part in 100,000, as measured by Kobe in 1992, and refined by WMAP and Planck, were seeded by quantum fluctuations during cosmic inflation and amplified to macroscopic scales by gravitational instability. These fluctuations would become the gravitational seeds of galaxies, galaxy clusters, and the entire large-scale structure of the observable universe. Cosmic inflation, proposed by Alan Guth, born 1947, American physicist at MIT, in 1980, published 1981, posits that in the first approximately 10 to the negative 32 seconds after the Big Bang, the universe underwent a period of exponential expansion, increasing in size by a factor of at least 10 to the 26 in linear dimensions. To put this in perspective, a region smaller than a proton, approximately 10 to the negative 15 meters, approximately 10 to the negative 13 inches, expanded to a volume larger than the observable universe today in a fraction of a trillionth of a trillionth of a trillionth of a second. The expansion was driven by the potential energy of a scalar field, the inflaton, in a high-energy false vacuum state that decayed to a lower-energy true vacuum, releasing enormous energy. Inflation was a theoretical triumph. It solved three long-standing puzzles in Big Bang cosmology. The horizon problem. The cosmic microwave background has almost exactly the same temperature, 2.725 Kelvin, uniform to 1 part in 100,000 in all directions of the sky, including regions that, in the standard Big Bang model without inflation, were never in causal contact. They could never have exchanged signals at the speed of light. How then are they at the same temperature? Inflation answers. Before inflation, all these regions were in causal contact within a tiny volume. The exponential expansion stretched this connected region to a size far larger than our observable universe, ensuring temperature uniformity everywhere we can see. The flatness problem. The spatial geometry of the universe is extraordinarily close to flat. Omega total approximately equals 1, confirmed by the Planck satellite to within 0.2%. In the standard Big Bang model without inflation, even a tiny deviation from flatness early on would have been amplified by billions of years of expansion, producing a universe that is obviously curved, either positively, closed, eventually recollapsing, or negatively, open, expanding forever with visible negative curvature. The fact that omega is still approximately 1 after 13.8 billion years of expansion requires the initial density to have been fine-tuned to extraordinary precision at the Planck epoch. Inflation solves this by driving the geometry toward flatness, regardless of the initial curvature. The exponential expansion stretches any curvature to invisibility, like inflating a balloon until its surface appears flat. The monopole problem. Grand unified theories of particle physics predict that magnetic monopoles, hypothetical particles carrying isolated north or south magnetic charge, should have been produced in abundance during the high-energy conditions of the early universe. None have been observed. Inflation solves this by diluting any monopoles produced before or during inflation to undetectable densities. The exponential expansion spreads them across a volume so vast that the probability of finding one in our observable universe is negligible. Inflation also provides the mechanism for generating the primordial density fluctuations that seeded the large-scale structure of the cosmos. During inflation, quantum fluctuations in the inflaton field, governed by the Heisenberg uncertainty principle, delta x times delta p greater than or equal to h bar over 2, were stretched from subatomic scales, approximately 10 to the negative 28 meters, to macroscopic and then cosmological scales by the exponential expansion. These fluctuations became the tiny density variations, approximately 1 part in 100,000, imprinted on the cosmic microwave background and detected by COBE in 1992, refined by WMAP and mapped with extraordinary precision by the Planck satellite. The Planck data confirmed the nearly scale-invariant spectrum of these fluctuations, spectral index n sub s approximately equals 0.965, and their Gaussian statistics, both predictions of inflationary models. These density fluctuations are the seeds of everything we see. The regions with slightly higher density attracted more matter through gravitational instability, growing denser over hundreds of millions of years, collapsing into the first dark matter halos, attracting baryonic matter, forming the first stars, the first galaxies, the first galaxy clusters. The regions with slightly lower density became the voids, the enormous, nearly empty spaces between galaxy clusters, some spanning hundreds of millions of light years. The cosmic web, the filamentary network of galaxies and galaxy clusters connected by dark matter filaments with vast voids between them, is a direct consequence of those primordial quantum fluctuations, amplified by inflation and sculpted by gravity over 13.8 billion years. Imagine the cosmic web as a camera might see it from a distance of billions of light years. Filaments of luminous galaxies stretching across hundreds of megaparsecs, bright strands of light against the darkness, intersecting at nodes where galaxy clusters sit, each cluster containing hundreds to thousands of galaxies, each galaxy containing hundreds of billions of stars. Between the filaments, voids, dark, nearly empty regions, some hundreds of millions of light years across, containing almost no galaxies, almost no light. The structure is vast, intricate, and specific, determined by the precise pattern of quantum fluctuations imprinted during inflation, amplified by gravity, and shaped by the specific values of the cosmological constants. Every element of this structure was decided before consciousness existed. The quantum fluctuations during inflation, approximately 10 to the negative 35 seconds after the Big Bang, were decided by decoherence as the inflaton field interacted with the rapidly expanding spacetime. The gravitational collapse of dark matter halos, beginning approximately 100 million years after the Big Bang, was decided by Newtonian gravity and general relativity, operating on the density fluctuations seeded during inflation. The nuclear reactions in the first stars, beginning approximately 200 million years after the Big Bang, were decided by quantum mechanics and nuclear physics, operating according to the strong force coupling, the electromagnetic force and the weak force. The supernova explosions that scattered heavy elements, beginning a few million years after the first stars formed, were decided by the Chandrasekhar limit, the nuclear physics of iron core collapse, and the hydrodynamics of the rebounding shock wave. None of these processes waited for consciousness. None required an observer. none depended on a mind to become real. The universe was decided, structurally, physically, irrevocably, by the laws of physics operating on the initial conditions established at the Big Bang. Decoherence enforced classical outcomes at every quantum event. The environment selected pointer states through Ein selection. Quantum Darwinism broadcast pointer state information into the cosmic environment. The classical world, the world of definite positions, definite energies, definite chemical compositions, was established by physics, not by perception. The COBE satellite, the Cosmic Background Explorer, launched by NASA in November 1989 after a delay caused by the Challenger disaster, provided the first precise confirmation of the Big Bang's predictions about the CMB. COBE's FIRAS instrument measured the CMB spectrum and found it to be a near-perfect blackbody at 2.725 Kelvin, the most precise blackbody spectrum ever measured, with deviations of less than 1 part in 10 to the 4 from the theoretical Planck curve. COBE's DMR instrument detected the tiny anisotropies in the CMB temperature, fluctuations of approximately 1 part in 100,000 that represent the primordial density fluctuations seeded during inflation. George Smoot, upon seeing the anisotropy map for the first time, reportedly said it was like looking at the face of God, a phrase that captured the awe of seeing the earliest observable structure in the universe. Smoot and John Mather shared the 2006 Nobel Prize in Physics for COB's discoveries. WMAP, the Wilkinson Microwave Anisotropy Probe, launched by NASA in June 2001, mapped the CMB with much higher resolution than COBE, producing the first detailed baby portrait of the universe at 380,000 years old. WMAP determined the age of the universe at 13.77 plus or minus 0.06 billion years. The composition, approximately 4.9% baryonic matter, 26.6% dark matter, 68.5% dark energy, and the spatial geometry, flat to within 1%. WMAP's data, combined with other observations, established the lambda-CDM model, lambda cold dark matter, as the standard model of cosmology. The Planck satellite, launched by ESA in May 2009, provided the highest resolution CMB map ever produced. Planck's final data release in 2018 refined the cosmological parameters: age, 13.80 plus or minus 0.02 billion years, Hubble constant, 67.4 plus or minus 0.5 kilometers per second per megaparsec, spatial flatness confirmed to omega total equals 1.0007 plus or minus 0.0019, and the spectral index of primordial fluctuations, n sub s, equals 0.9649 plus or minus 0.0042, consistent with simple inflationary models. None of these observations required consciousness to produce their data. The CMB photons decoupled from matter at 380,000 years, 13.8 billion years before any conscious observer existed. The density fluctuations were seeded during inflation, approximately 10 to the negative 35 seconds after the Big Bang. The photons traveled through expanding space for 13.8 billion years before being detected by COBE, WMAP, and Planck. The satellites were automated instruments. The detectors were bolometers and radiometers. The data was recorded digitally and processed by computers. Human scientists analyzed the data months or years later. The physics occurred without consciousness. The universe was decided in every measurable, confirmable sense before any mind existed to observe it. The first stars, population 3 stars, massive and short-lived, composed of hydrogen and helium alone, formed approximately 100 to 200 million years after the Big Bang. These were not stars like the Sun. They were behemoths, estimated at 100 to 1,000 solar masses, burning through their fuel in a few million years. Their cores reached hundreds of millions of degrees, far hotter than the Sun's 15 million Kelvin core, fusing hydrogen into helium, helium into carbon through the triple alpha process, carbon into oxygen, oxygen into neon, neon into magnesium, magnesium into silicon, and silicon into iron. Iron is the terminus, the most stable nucleus, the endpoint of fusion energy production. When the iron core of a massive star exceeds the Chandrasekhar limit, approximately 1.4 solar masses, named after Subramanian Chandrasekhar, Indian-American astrophysicist, Nobel Prize 1983, the star collapses in a fraction of a second. The core compresses to nuclear density, approximately 10 to the 17 kilograms per cubic meter. The outer layers, still falling inward at a large fraction of the speed of light, rebound off the incompressible core in a supernova, a cataclysmic explosion that, for a few weeks, outshines the entire galaxy containing it. The supernova scattered heavy elements into the interstellar medium: carbon, the backbone of organic chemistry; oxygen, the most abundant element in the Earth's crust; silicon, the foundation of rock and sand; iron, the core of the Earth; gold, platinum, uranium, forged in the extreme conditions of neutron star mergers, confirmed by LIGO's detection of gravitational waves from a binary neutron star merger in August 2017. Every atom in your body, every carbon atom, every oxygen atom, every iron atom, was forged in a star that burned and died billions of years before you were born. You are made of stellar debris. And every step of that process, every nuclear reaction, every gravitational collapse, every supernova explosion was decided by physical processes and quantum decoherence, without a single conscious observer. The second generation of stars, population 2, formed from gas clouds enriched by the first supernovae. These stars contain small amounts of heavy elements. They are found today in the halos and globular clusters of galaxies, ancient metal-poor stars that provide a fossil record of the early universe's chemical development. The third generation, population 1, including our Sun, formed from gas enriched by multiple generations of stellar nucleosynthesis. The Sun, a G-type main sequence star, spectral class G2V, formed approximately 4.6 billion years ago from a cloud of gas and dust in the Orion arm of the Milky Way galaxy. The cloud collapsed under its own gravity, a process triggered, perhaps, by the shock wave of a nearby supernova. As the cloud contracted, it spun faster, conservation of angular momentum, flattened into a disk and heated at the center. When the core temperature reached approximately 10 million Kelvin, hydrogen fusion ignited, and the Sun began its main sequence lifetime. The Sun has a mass of approximately 1.989 times 10 to the 30 kilograms, approximately 4.385 times 10 to the 30 pounds, approximately 333,000 times the mass of the Earth. It has a radius of approximately 696,000 kilometers, approximately 432,000 miles, approximately 109 times the Earth's radius. It converts approximately 600 million tons of hydrogen into helium every second, releasing energy at a rate of approximately 3.828 times 10 to the 26 watts, approximately 3.828 times 10 to the 26 joules per second. The energy is produced by the proton-proton chain, a sequence of nuclear reactions that fuses 4 hydrogen nuclei into one helium nucleus, releasing approximately 26.7 million electron volts of energy per reaction. The Sun has been burning for 4.6 billion years. It will continue for approximately another 5 billion years. None of this required consciousness. The nuclear reactions proceeded according to quantum mechanics and statistical physics. Decoherence enforced classical outcomes at every step. The Earth formed from the accretion disk around the young Sun, dust grains colliding, sticking, growing into planetesimals kilometers across, then protoplanets hundreds of kilometers across, then the Earth, approximately 12,742 kilometers in diameter, approximately 7,918 miles, approximately 5.972 times 10 to the 24 kilograms, approximately 1.317 times 10 to the 25 pounds. The Moon formed approximately 4.5 billion years ago from the debris of a giant impact between the proto-Earth and a Mars-sized body called Theia. A collision so violent it melted both bodies, ejecting material into orbit that coalesced into the Moon. The Moon stabilized the Earth's axial tilt at approximately 23.4 degrees, preventing the chaotic oscillations that would otherwise make the climate unsuitable for complex life. This stabilization is another fine-tuned feature, one that was decided by the mechanics of the Theia impact, not by consciousness. Life appeared on Earth approximately 3.5 to 4 billion years ago. The earliest evidence, stromatolites, layered structures produced by microbial mats in shallow water, dated to approximately 3.5 billion years ago in Western Australia. The first organisms were single-celled prokaryotes, bacteria and archaea, without nuclei or organelles. For approximately 2 billion years, life remained single-celled. The Great Oxidation Event, approximately 2.4 billion years ago, occurred when cyanobacteria began producing oxygen through photosynthesis, transforming the atmosphere from reducing methane, carbon dioxide, to oxidizing oxygen. Multicellular life appeared approximately 600 million years ago. The Cambrian explosion, approximately 540 million years ago, produced the rapid diversification of animal body plans that populate the fossil record. The first organisms with nervous systems, simple nerve nets, appeared in the Cambrian. The first vertebrates appeared approximately 525 million years ago. The first land plants approximately 470 million years ago. The first mammals approximately 225 million years ago. The first primates approximately 65 million years ago. Homo sapiens, modern humans with prefrontal cortex, Broca's area, Wernicke's area, the neural architecture of abstract thought, language and conscious self-reflection, appeared approximately 300,000 years ago. 300,000 years out of 13.8 billion years. The ratio, 46,000 to 1. Consciousness, the kind of consciousness invoked by the consciousness creates reality claim, is a latecomer, a fraction of cosmic history. The universe did not wait. It was decided from the beginning by physical laws, quantum decoherence, gravitational collapse, nuclear physics, and the specific configuration of initial conditions. Not by consciousness, not by observation, not by mind. Second, the decoherence mechanism. This brings us to quantum decoherence, the physical mechanism that explains how the universe was decided without consciousness, and to the mathematics, the measurements, and the experiments that confirm it. Quantum mechanics describes physical systems using wave functions. The Schrödinger equation, formulated by Erwin Schrödinger in 1926, Austrian physicist, born 1887, died 1961, Nobel Prize 1933, governs the development of these wave functions. I(h) bar times the partial derivative of psi with respect to t equals h hat times psi. I is the imaginary unit, the square root of -1. H bar is the reduced Planck constant, approximately 1.055 times 10 to the -34 joule seconds, the fundamental quantum of action, the smallest packet of energy times time that characterizes quantum physics. Psi is the wave function, the mathematical object encoding all information about the quantum state, a complex-valued function with both amplitude and phase. H hat is the Hamiltonian operator, representing the total energy, kinetic plus potential, of the system. The equation is deterministic. Given the wave function at one time, it uniquely determines the wave function at all future times. The equation is linear. If psi sub 1 and psi sub 2 are both solutions, then any linear combination A times psi sub 1 plus B times psi sub 2 is also a solution. This linearity is the mathematical origin of superposition, the defining feature of quantum mechanics. Superposition means that a quantum system can exist in a combination of multiple states simultaneously. An electron can be in a combination of spin up and spin down. A photon can traverse both arms of an interferometer at the same time. An atom can be in a superposition of decayed and not decayed, the situation dramatized by Schrödinger's famous thought experiment in 1935, in which a cat inside a sealed box is simultaneously alive and dead until the box is opened. The thought experiment was not meant to describe reality. It was meant to expose the absurdity of applying superposition to macroscopic objects. And decoherence explains why the absurdity does not occur. The cat, composed of approximately 10 to the 28 atoms, interacts with its environment, air molecules, thermal radiation, photons from the laboratory lights, and decoheres in a time so short it cannot be meaningfully measured. The cat is always alive or dead, never both. Decoherence has already enforced a classical outcome long before any conscious observer opens the box. The Born rule, proposed by Max Born in 1926, German physicist, born 1882, died 1970, Nobel Prize 1954, connects the wave function to measurement outcomes. The probability of outcome I equals the squared magnitude of the amplitude for that outcome. P sub I equals the magnitude of the inner product of phi sub I and psi squared. This rule is confirmed by every quantum experiment ever performed. It is not derived from the Schrödinger equation. It is an additional postulate, an empirical rule that introduces probability into an otherwise deterministic framework. The tension between the deterministic Schrödinger equation and the probabilistic Born rule is the heart of the measurement problem. The Heisenberg uncertainty principle, formulated by Werner Heisenberg in 1927, German physicist, born 1901, died 1976, Nobel Prize 1932, establishes a fundamental limit. Delta x times delta p is greater than or equal to h bar over 2. Delta x is the uncertainty in position. Delta p is the uncertainty in momentum. The product cannot be reduced below h bar over 2, not because of limitations in instruments, but because of the intrinsic structure of quantum mechanics. This principle governs the quantum fluctuations during inflation that seeded the large-scale structure of the universe, fluctuations that were decided by decoherence, not by consciousness. The measurement problem arises because the Schrödinger equation preserves superpositions, but measurements yield single, definite outcomes. John von Neumann, born 1903, died 1957, Hungarian-American mathematician and physicist, formalized this in his 1932 book Mathematical Foundations of Quantum Mechanics, showing that the measurement chain can be extended indefinitely. System entangled with apparatus, apparatus entangled with environment, environment entangled with observers' sensory organs, sensory organs entangled with brain. Each link enters a superposition entangled with the previous one. The chain must terminate somewhere, but von Neumann showed that the mathematics does not specify where. Neumann-Wigner, born 1902, died 1995, Hungarian-American physicist, Nobel Prize 1963 for contributions to nuclear physics and symmetry principles, proposed in a 1961 essay that the chain terminates at consciousness. When a conscious mind becomes aware of the result, the superposition collapses. Without consciousness, reality remains indeterminate. This is the von Neumann-Wigner interpretation. This claim is wrong. It is contradicted by decoherence, abandoned by its own originator, rejected by every mainstream interpretation of quantum mechanics, and refuted by 13.8 billion years of cosmic history. Let us examine why with the precision the subject demands. H. Dieter Zeh, born 1927, died 2018, German physicist, first analyzed decoherence formally in the 1970s. Zeh recognized that the measurement problem could be fundamentally reframed by taking the environment seriously. Every quantum system, every electron, atom, molecule, measurement apparatus, cat, planet, interacts with its environment. No laboratory is perfectly isolated. No particle exists in a true vacuum. Even interstellar space contains cosmic microwave background photons at 2.725 Kelvin, cosmic dust, neutrinos, and gravitational fluctuations. These environmental interactions entangle the system with its surroundings, and this entanglement destroys the quantum coherence, the phase relationships between different components of the superposition that distinguishes quantum behavior from classical behavior. Wojciech Zurek, born 1955, Polish-American physicist at Los Alamos National Laboratory, developed the theory extensively from the 1980s onward, transforming decoherence from a qualitative insight into a precise quantitative framework. Zurek introduced three key concepts. First, einselection, environment-induced superselection. The specific form of the system-environment interaction determines which system states survive environmental monitoring. If the environment couples to position, as photon scattering does for macroscopic objects, then position eigenstates become the pointer states, the states that are resilient against decoherence, the states that behave classically. Energy eigenstates become pointer states for atoms in certain environments. The classical world is not arbitrary. It is selected by the environment through the specific physics of system-environment interactions. Second, pointer states. These are the states that survive decoherence, the classically observed states. For macroscopic objects, definite positions. For measured particles, definite spin orientations. For atoms, definite energy levels. The pointer states are the states whose information the environment records and preserves. All other states, fragile superpositions that the environment destroys, are eliminated by decoherence. The classical world consists of pointer states, selected by einselection, enforced by the environment. Third, quantum Darwinism. Not only does the environment cause decoherence, it broadcasts information about the pointer states. When photons scatter off an object, they carry information about the object's position, size, and shape into the environment. Each photon is a witness to the object's state. Multiple independent observers can access different fragments of the environment, different photons, different scattered particles, and extract the same information about the object. The pointer states are the states whose information is redundantly encoded across many environmental fragments. Classical reality appears objective because the environment has broadcast pointer state information to all potential observers. The observer does not create the result. The environment has already selected it, recorded it, broadcast it, and made it available to anyone or anything that interacts with the environmental record. The mathematics is implemented through the density matrix, the mathematical representation of a quantum state that accounts for statistical mixtures and entanglement. In a closed system, the density matrix develops unitarily according to von Neumann's equation. But when the system interacts with an environment, the reduced density matrix, obtained by tracing out, mathematically discarding the environmental degrees of freedom, loses its off-diagonal elements. These off-diagonal terms encode the coherent superposition. Their decay is exponential, governed by the Lindblad master equation, which adds irreversible decoherence terms to the unitary development. The result? The reduced density matrix becomes diagonal, a classical probability distribution. The system is in one state or another, with probabilities given by the Born rule. The superposition has been replaced by a classical mixture. No consciousness required, no observer needed. The environment, photons, molecules, thermal radiation, gravitational fields, has done the work. The timescales are measured, and they are staggering. A dust grain, approximately 10 micrometers in diameter, approximately the width of a cotton fiber, approximately 4/10,000ths of an inch, loses quantum coherence in approximately 10 to the negative 31 seconds upon interacting with a single cosmic microwave background photon. 10 to the negative 31 seconds. A billionth of a billionth of a billionth of a millionth of a second. A nitrogen molecule in air at room temperature decoheres via molecular collision in approximately 10 to the negative 36 seconds, 100,000 times faster than the dust grain. A macroscopic object at room temperature, a baseball, a cat, a measurement apparatus, a human brain, decoheres so rapidly that the superposition lifetime is effectively zero. There is no window of time in which a macroscopic object exists in a quantum superposition under ordinary conditions. Decoherence is not slow. It is not gradual. For macroscopic objects, it is effectively instantaneous. These are not speculative estimates. They are calculated from known interaction cross-sections and confirmed experimentally. Quantum computing provides the most direct confirmation. IBM's and Google's multi-qubit processors must be cooled to approximately 15 millikelvin, colder than outer space, and shielded from electromagnetic interference to maintain quantum coherence for microseconds to milliseconds. Even with this extraordinary isolation, decoherence remains the primary obstacle to quantum computation. The moment a qubit interacts with an uncontrolled environmental degree of freedom, a stray photon, a thermal vibration, a cosmic ray, coherence is lost. Google's Sycamore processor, which demonstrated quantum computational advantage in 2019, operated with qubits that maintained coherence for approximately 20 microseconds before decohering. 20 microseconds in a system cooled to near absolute zero and shielded from every environmental influence, engineers could eliminate. In nature, without cryogenic cooling and electromagnetic shielding, decoherence is the default. Classical behavior is the default. Quantum coherence is the rare exception, maintained only in microscopic systems or under extreme laboratory conditions. Wigner himself recognized this. After learning of Zer's decoherence work in the 1970s, Wigner abandoned the consciousness collapse interpretation. He called it a form of solipsism, the philosophically untenable position that only one's own mind is guaranteed to be real. This is not a minor footnote. The most prominent advocate of consciousness collapse, the Nobel laureate whose name is attached to the interpretation, examined the evidence from decoherence and concluded that his own proposal was wrong. He withdrew it. He rejected it. The postulate that consciousness causes collapse was largely abandoned by the physics community by the 1970s and 1980s. This is documented in the physics literature. The consciousness interpretation of quantum mechanics is not an open question in physics. It is a closed case, closed by the physicist who opened it. Niels Bohr, the founder of the Copenhagen interpretation, born 1885, died 1962, Danish physicist, Nobel Prize 1922, had rejected the need for a conscious observer decades earlier. According to Werner Heisenberg's account, Bohr insisted that the measurement apparatus is a classical device, not a conscious mind, and that the observer's only role is to choose the experimental setup, not to cause the outcome. Bohr's position was explicitly anti-consciousness. The popular misunderstanding that the observer in quantum mechanics means a conscious human is a misreading of Copenhagen, amplified by popular science books, New Age documentaries like What the Bleep Do We Know, 2004, and motivational speakers who quote quantum mechanics without understanding it. The double-slit experiment explained, the most frequently misquoted experiment in all of physics, deserves careful treatment because it is the experiment most commonly cited by consciousness advocates. In the standard double-slit setup, particles, photons, electrons or molecules are sent one at a time toward a barrier with two slits. If no detector monitors which slit the particle passes through, the particles accumulate in an interference pattern on the detection screen, alternating bright and dark bands, the hallmark of wave-like behavior. If a which path detector is placed at the slits, the interference pattern vanishes. The particles accumulate in two bands behind the slits, as if they were classical particles. The consciousness interpretation claims that conscious observation destroys interference. The particle remains in superposition until a mind becomes aware of which path it took. This is wrong. The interference vanishes because of the physical interaction between the detector and the particle. The detector becomes entangled with the particle, acquiring which path information, and this entanglement destroys the coherence between the two path components. Decoherence, physical, measurable, calculated, destroys the interference. An automated detector with no human observer produces exactly the same result. A photon detector connected to a computer that records the data but is never read by a human destroys the interference pattern identically. The key variable is physical entanglement, not conscious observation. This distinction between the observer effect and measurement in quantum mechanics is critical. This has been confirmed experimentally with increasing precision and with increasingly large particles. In 1989, Akira Tonomura, Japanese physicist, demonstrated the double-slit experiment with individual electrons, showing that each electron arrives at the screen as a single dot, particle-like. But over thousands of electrons, the dots build up into an interference pattern, wave-like. No consciousness collapsed each electron. The detector, a fluorescent screen, recorded each impact through physical interaction alone. The interference pattern emerged from the ensemble statistics, exactly as the Born rule predicts, with no conscious observer present during the individual detections. In 1999, Anton Zeilinger's group in Vienna demonstrated interference with fullerene molecules, C60, Buckminster fullerene, molecules containing 60 carbon atoms with a diameter of approximately 0.7 nanometers. The fullerenes passed through a diffraction grating and produced clear interference fringes. When the vacuum was degraded, allowing residual gas molecules to collide with the fullerenes, the interference vanished. The decoherence was caused by molecular collisions with the residual gas, not by conscious observation. No one watched the individual molecules. The environment, residual gas molecules at finite pressure, destroyed the coherence. The Davison-Germer experiment of 1927, Quinton Davison and Lester Germer, American physicists, provided the first experimental confirmation of wave-particle duality by demonstrating electron diffraction from a nickel crystal surface. Electrons, fired at the crystal, produced diffraction patterns matching the wavelengths predicted by the de Broglie relation, lambda equals h over p, where h is Planck's constant and p is the electron's momentum. The diffraction occurred through physical interaction with the crystal lattice, not through conscious observation. The experiment confirmed quantum mechanics and wave-particle duality decades before any discussion of consciousness collapse. The delayed choice experiment, proposed by John Archibald Wheeler, adds another dimension that is frequently misinterpreted. In a delayed choice configuration, the decision of whether to measure which path or interference is made after the particle has already passed through the slits. The result appears to show that the particle retroactively changes its behavior, displaying interference if the experimenter chooses the interference measurement, and particle-like behavior if the which path measurement is chosen. Wheeler described the observer as a participant in defining the past. This has been widely misquoted as evidence that consciousness determines reality retroactively. The correct interpretation is physical. The delayed choice experiment demonstrates that the measurement apparatus determines which quantum observable is realized, not that consciousness retroactively creates the particle's history. The result is the same whether the measurement apparatus is configured by a human or by an automated random number generator. Wheeler himself later clarified that the participant concept does not imply mystical creation by mind. The apparatus is physical. The choice of observable is physical. Consciousness is not required. The quantum eraser experiment, in which path information is recorded and then erased by a subsequent measurement, restoring interference in the correlated subset of data, is equally misrepresented. The quantum eraser demonstrates that quantum correlations, entanglement, between the particle and the Witch path record can be manipulated by physical measurements. The erasure is a physical operation on the entangled system, not an act of consciousness. An automated apparatus produces the same result. No mind is needed to erase information. The physics is entanglement and measurement correlation. The Bell test experiments, first conducted by Alain Aspect in 1982 at the Institut d'Optique in Orsay, France, confirmed that quantum entanglement is real and that no local hidden variable theory can reproduce quantum predictions. Aspect used pairs of entangled photons produced by calcium atoms excited by lasers, sent to detectors separated by approximately 12 meters, approximately 39 feet. The key innovation: rapidly switching polarizers changed the measurement setting every 10 nanoseconds, faster than light could travel between the detectors, ensuring that no signal could communicate the setting from one detector to the other. The result? Bell's inequality was violated by approximately 5 standard deviations, exactly as quantum mechanics predicted. Modern Bell tests achieve violations exceeding 10 standard deviations, with detection efficiencies above 98%. Aspect, John Clauser, and Anton Zeilinger shared the 2022 Nobel Prize in Physics. The experiments were performed with photon detectors, not conscious observers. The results were recorded electronically and analyzed later. No human was present at the moment of detection. The physics occurred without consciousness. The quantum teleportation experiment of 1997, conducted by Dirk Baumeister and colleagues, demonstrated the transfer of a photon's quantum state to a distant photon using entanglement and classical communication. The experiment illustrates that quantum information can be manipulated and transferred through physical processes, not through consciousness. The protocol requires decoherence control and would not work with macroscopic objects, precisely because decoherence would destroy the quantum state immediately. Before we continue, consider what all of this means for the popular claim that you create your own reality. The physics says the opposite. Every experiment ever performed shows that physical detectors produce the same results as conscious observers. Every decoherence calculation shows that the environment enforces classical outcomes at timescales of 10 to the negative 31 seconds. Far too fast for any neural process, which operates on timescales of milliseconds, to play a role. Every interpretation of quantum mechanics, except the one abandoned by its originator, works without consciousness. The claim survives not because the physics supports it, but because it tells people what they want to hear: that they are cosmically important, that their mind shapes reality, that they are participants in creation. The evidence says otherwise. The environment shapes reality. Consciousness is a witness, not a creator. This is the part that stays with me, not the equations, the timeline. The universe operated for 13.8 billion years with decoherence enforcing classical outcomes at every quantum event, every nuclear reaction in every star, every photon scattering off every dust grain, every gravitational interaction between every galaxy. All of it decided by the environment. None of it waiting for a conscious mind. The claim that you create your own reality is not merely unsupported, it is the opposite of what the physics shows. You did not create the carbon in your body. The carbon was forged in a star that burned and died billions of years before you were born. You did not create the laws of nuclear fusion that produced it. You did not create the gravitational constant that collapsed the protostellar cloud. You are a witness, a late-arriving observer in a universe that was fully functional, fully decided, and fully governed by objective physical laws for 13.8 billion years before you opened your eyes. Third, the interpretation survey. This brings us to the interpretations of quantum mechanics and to the critical point that not a single mainstream interpretation requires consciousness to explain measurement outcomes. The Copenhagen interpretation, associated with Niels Bohr, born 1885, died 1962, Danish physicist, Nobel Prize 1922, and Werner Heisenberg, born 1901, died 1976, German physicist, Nobel Prize 1932, is the oldest and most widely taught interpretation. Copenhagen holds that measurement by a macroscopic apparatus causes collapse. The quantum system collapses to one of the apparatus's pointer states, with probabilities given by the Born rule. The apparatus is treated as inherently classical. The observer in Copenhagen is the measuring device, not a conscious mind. Bohr explicitly rejected the need for consciousness. According to Heisenberg's recollection, Bohr insisted that the observer plays no active role in collapse beyond selecting the experimental setup, choosing what to measure, not causing the outcome. Copenhagen has been criticized for introducing a vague classical quantum cut, a boundary between the quantum system and the classical apparatus that is never precisely defined, and for adding the collapse postulate ad hoc without deriving it from the Schrödinger equation. John Bell called the interpretation unprofessionally vague. But whatever its weaknesses, Copenhagen does not invoke consciousness. Its observer is a piece of laboratory equipment. The many worlds interpretation, proposed by Hugh Everett III, born 1930, died 1982, American physicist, takes a radically different approach. Everett took the Schrödinger equation at face value. It is universal, it never breaks down, and there is no collapse. When a measurement is performed, the Schrödinger equation predicts that the system plus apparatus plus observer enters a superposition of all possible outcomes. Everett proposed that all these outcomes are real, each in a separate branch of the universal wave function. When you measure a spin and see up, there is another branch where you see down. Both exist. Both are equally real. Decoherence defines the branches, making them effectively non-interacting. Many worlds is the most radically anti-consciousness interpretation of quantum mechanics. It eliminates the observer's special role entirely. No outcome is selected. No collapse occurs. No conscious mind is needed to make reality definite. Every possibility is realized in a separate branch of the universal wave function. The interpretation has notable weaknesses. It multiplies unobservable entities to infinity, an infinite number of branching universes for every quantum event that has ever occurred, and it struggles to derive the Born rule, to explain why we observe outcomes with frequencies proportional to the squared amplitude. But for our purposes, the key point is absolute. Many worlds does not require consciousness. It eliminates the observer from physics. Bohmian mechanics, the pilot wave theory, developed by David Bohm, born 1917, died 1992, American physicist, offers a deterministic alternative. In Bohm's theory, particles have definite positions at all times. There is no superposition of macroscopic objects. There is no collapse. The wave function is a real physical field, a pilot wave that guides particles along definite trajectories. The apparent randomness of quantum mechanics arises from ignorance of the particle's initial positions, not from fundamental indeterminacy. Bohm himself noted that environmental interactions destroy interference, a concept he developed before Zay's formal decoherence theory. Bohmian mechanics reproduces all the predictions of standard quantum mechanics. It requires no consciousness, no observer, and no mind. The double-slit experiment has a clear explanation. The particle goes through one slit, the pilot wave goes through both, and the wave guides the particle to regions of constructive interference. No mystery, no consciousness, no observer creates reality. Objective collapse theories, the GRW model proposed by Giancarlo Ghirardi, Alberto Rimini and Tullio Weber in 1986, and Roger Penrose's gravity-induced collapse proposal from 1989 modify the Schrödinger equation by adding a physical mechanism for collapse. In GRW, every particle has a small probability, approximately 10 to the negative 16 per second, of undergoing a spontaneous localization. For a single particle, this rate is negligible. For a macroscopic object with 10 to the 23 particles, at least one particle collapses every 10 to the negative 7 seconds, dragging the entire entangled wave function into a definite state. In Penrose's model, gravitational effects trigger collapse when superpositions involve sufficiently different mass distributions at or above the Planck mass threshold. In both models, collapse is physical. It occurs whether or not anyone is observing. Consciousness is irrelevant. The consistent histories interpretation, Robert Griffiths, 1984, Roland Omnes, 1994, reformulates quantum mechanics in terms of decoherent histories rather than collapse events. A history is a sequence of quantum states at different times. The framework assigns probabilities to consistent sets of histories, sets where the histories decohere and do not interfere with each other. No observer or collapse postulate is needed. The relational interpretation, Carlo Rovelli, 1996, treats quantum states as relative to the observer-system pair. But observer here means any physical system, not a conscious mind. A photon detector is an observer. A rock is an observer. Consciousness is not required. The transactional interpretation, John Kramer, 1986, proposes that quantum events involve both forward in time and backward in time waves that form a handshake to determine outcomes. The interpretation provides a pictorial account of non-locality. It does not require consciousness. None of these interpretations requires consciousness. Copenhagen invokes a physical apparatus. Many worlds eliminates collapse entirely. Bohmian mechanics is deterministic. Objective collapse models propose physical mechanisms. Consistent histories uses decoherent histories. Relational QM uses physical reference frames. Transactional QM uses wave handshakes. The consciousness interpretation, proposed in 1961, abandoned by its originator in the 1970s, classified as largely abandoned by the physics community by the 1970s and 1980s, is the single outlier. It has no experimental evidence. It makes no testable predictions that differ from standard quantum mechanics. And it is contradicted by 13.8 billion years of cosmic history, in which decoherence operated without a conscious observer. Robert Lanza, born 1956, American biologist, published Biocentrism: How Life and Consciousness Are the Keys to Understanding the True Nature of the Universe in 2007. The book argues that consciousness is fundamental and that the universe is created by conscious observers. Let us apply the prosecution after defense model with full rigor. The defense. Lanza argues that quantum mechanics demonstrates the observer's centrality. The double-slit experiment shows observation determines outcomes. The measurement problem shows reality is indeterminate without observers. Space and time are constructs of consciousness, not objective containers. The cross-examination. What does biocentrism actually explain? It claims consciousness creates reality, but does not define consciousness in physical terms. It provides no mechanism by which consciousness interacts with quantum systems. No equation, no coupling constant, no Hamiltonian. It makes no testable predictions that differ from standard quantum mechanics. It does not explain decoherence. It does not explain how the universe existed for 13.8 billion years before conscious life appeared. How stars formed, elements were forged, planets coalesced, all without a conscious observer. It does not explain why the Planck satellite COBE, WMAP, and LIGO produce results consistent with objective physics, not observer-dependent reality. The prosecution. Biocentrism is not physics. It is a philosophical claim, idealism, dressed in quantum language. It misrepresents the double-slit experiment by conflating physical detection with conscious observation, ignoring automated detectors and decoherence experiments. It ignores decoherence. It is unfalsifiable. Any observation is made by a conscious observer. So, biocentrism claims the observation was created by that observer. Circular reasoning. It is pseudoscience. The verdict. Biocentrism fails every test of scientific validity. Falsifiability, predictive power, mechanism, consistency with established physics. The claim that consciousness creates reality is contradicted by decoherence, abandoned by the physicist who originally proposed consciousness collapse, rejected by the physics community, and refuted by every experiment that has tested detectors versus conscious observers. This is the part that stays with me. Not the equations, the timeline. The universe operated for 13.8 billion years with decoherence enforcing classical outcomes at every quantum event, every nuclear reaction in every star, every photon scattering off every dust grain, every gravitational interaction between every galaxy. All of it decided by the environment, none of it waiting for a conscious mind. You did not create the carbon in your body. It was forged in a star that burned and died billions of years before you were born. You did not create the laws of nuclear fusion. You did not create the gravitational constant. You are a witness, a late arriving observer in a universe that was fully functional, fully decided, and fully governed by objective physical laws for 13.8 billion years before you opened your eyes. Fourth, the fine-tuning evidence. This brings us to the deeper question, the question that decoherence answers and consciousness mysticism avoids. If consciousness did not decide the universe, what did? The fine-tuning of the physical constants demands an answer. And the fine-tuning is not a philosophical argument imposed on the data, it is a feature of the data, acknowledged by secular physicists, measured to extraordinary precision and unexplained by any known naturalistic theory. The fine structure constant, alpha, equals e squared over 4 pi epsilon sub 0 h bar c. E is the electron charge, approximately 1.602 times 10 to the negative 19 coulombs. Epsilon sub 0 is the vacuum permittivity, approximately 8.85 times 10 to the negative 12 farads per meter. H bar is the reduced Planck constant. C is the speed of light, 299,792 kilometers per second, approximately 186,282 miles per second. Alpha is dimensionless. It has no units. Its value is approximately 1 over 137.036. This single number determines the strength of the electromagnetic interaction, how tightly electrons bind to nuclei, how atoms interact with light, how chemical bonds form, how fast chemical reactions proceed. If alpha were a few percent larger, stellar nucleosynthesis would fail. No carbon, no oxygen, no complex chemistry. If a few percent smaller, stable atoms would not form, and the periodic table would be radically different. The value is measured to extraordinary precision by atomic clock experiments at NIST, stable to parts in 10 to the 17 over years. No theory derives this value from first principles. It is a brute fact, one that permits atoms, molecules, chemistry, and biology. A different value, outside a narrow range, would render the universe sterile. The strong nuclear force coupling, the constant determining the strength of the force binding quarks into protons and neutrons, and binding protons and neutrons into nuclei, must be calibrated with similar precision. If the strong force were approximately 2% stronger, diprotons would be stable. 2 protons would bind without a neutron, and hydrogen, the simplest atom, the fuel of main sequence stars, the component of water, would not exist. If approximately 2% weaker, deuterium would not bind, and stellar fusion would fail. The margin is approximately 4% of the coupling strength. 4%. Between a universe with stars, chemistry and the conditions for complexity, and a universe with none of these things. The Planck-Einstein relation, E equals h times f, connects photon energy to frequency. The cosmic microwave background fits a perfect black-body spectrum predicted by this relation, confirmed by Kobe's Firas instrument to an accuracy of 1 part in 10 to the 4. If Planck's constant were different, all of quantum mechanics, chemistry, and atomic physics would operate differently. Einstein's mass-energy equivalence, E equals mc squared, relates mass and energy. The total mass energy of the observable universe is approximately 10 to the 70 joules. The composition, approximately 4.9% ordinary matter, 26.8% dark matter, 68.3% dark energy. The cosmological constant, the energy density of empty space, is approximately 10 to the negative 122 in Planck units. The natural value predicted by quantum field theory is of order 1 in Planck units, 122 orders of magnitude larger than observed. This is the largest discrepancy between prediction and observation in the history of physics. If the cosmological constant were the natural value, no structures could form. The Friedmann equation, derived by Alexander Friedmann in 1922 from Einstein's general relativity, governs cosmic expansion. The square of the Hubble parameter equals 8 pi g over 3 times rho minus k over a squared plus lambda over 3. The flatness of the universe, omega approximately equals 1, requires the initial energy density at the Planck epoch, approximately 10 to the negative 44 seconds after the Big Bang, to have been fine-tuned to approximately 1 part in 10 to the 60. If slightly above critical density, the universe would have recollapsed before structures could form. If slightly below, expansion would have been too rapid for gravitational collapse into galaxies and stars. Stephen Hawking, born 1942, died 2018, British physicist, observed that the laws of science contain many fundamental numbers whose values are very finely adjusted to make possible the development of life. Hawking was not a theist. He favoured multiverse explanations. But his words describe what the data shows. Paul Davies, born 1946, British cosmologist, stated that it seems as though somebody has fine-tuned nature's numbers to make the universe, creating an overwhelmingly life-friendly universe. Davies has described himself as closer to deism. His language is explicit. Somebody, fine-tuned, life-friendly. Roger Penrose, born 1931, British mathematician, Nobel Prize 2020, calculated the probability of the universe's initial conditions occurring by chance. Examining the gravitational degrees of freedom at the Big Bang, the Weyl curvature tensor, Penrose determined that the probability of randomly obtaining the observed low entropy, structure-enabling initial state is approximately 1 in 10 to the power of 10 to the 123. This number cannot be written in standard notation. It exceeds every physical quantity. Penrose called the initial state absurdly unlikely by chance. Think about those quotations and that number. Take a moment. These are not theists. These are secular physicists describing the evidence. And the language they use, finely adjusted, fine-tuned, somebody, absurdly unlikely, is the language of intention, precision, and purpose. What would you conclude from this evidence if you followed it honestly? The materialist response is the multiverse, an infinite ensemble of universes with different constants. We observe life-friendly values because only they permit observers. The anthropic principle. Let us apply the prosecution after defense model. The defense? The multiverse is proposed in eternal inflation and the string landscape, approximately 10 to the 500 possible vacuum states, as described by Leonard Susskind. It provides a framework where fine-tuning is not mysterious. We observe what we must observe to exist. The cross-examination. The multiverse has zero observational evidence. No other universe has been observed, measured, or detected. The theory is unfalsifiable. The anthropic principle is circular. We observe these constants because we exist, and we exist because these constants permit existence. This explains nothing. The prosecution. The multiverse is not science. It violates parsimony, positing infinite unobservable universes instead of one. Even if infinite universes existed, the mechanism generating them requires its own laws, initial conditions, and fine-tuning. Where did the laws of inflation come from? Why does the string landscape have its specific structure? The problem is not solved, it is multiplied. Victor Stenger argued fine-tuning is illusory, but his argument assumes all parameter values are equally likely, itself an unjustified assumption. Susskind acknowledged that anthropic predictions were once scorned by physicists as giving up on explanation. The verdict. The multiverse is not an explanation. It is an escape route. The evidence still points one direction. Science will eventually explain it is not an argument. It is faith. Faith in future discoveries deployed to avoid a present conclusion. Science describes how systems evolve within a framework. It cannot explain why the framework exists. The Schrödinger equation describes quantum dynamics. It does not explain why the Schrödinger equation holds. The Born rule gives correct probabilities. It does not explain why probabilities take this form. The fine structure constant is 1 over 137. No theory derives it. The cosmological constant is 10 to the negative 122 in Planck units. No theory explains it. Using science of the gaps to avoid a conclusion is no more rational than the God of the gaps accusation. The difference? The evidence for a creator is present now. The consciousness argument, the hard problem identified by David Chalmers, is directly relevant. Consciousness exists. We have established it did not create the universe. But its existence in a universe of unconscious particles demands explanation. Atoms have no awareness. Molecules have no thoughts. Neurons fire electrochemical signals, approximately 100 billion neurons, 100 trillion synaptic connections. But the transition from physical activity to subjective experience has no materialist explanation. Correlation is not explanation. How does the firing of neurons produce the experience of seeing red? How does electrochemical activity become grief? The hard problem remains unsolved. The consciousness mystics exploit this gap by claiming consciousness is fundamental. We have examined this claim exhaustively. Decoherence refutes it. The timeline refutes it. Every interpretation refutes it. Wigner abandoned it. But the gap is real. Consciousness exists. It arrived 13.8 billion years late, but it arrived. And its existence is not explained by materialism. Fifth, creator inference. Now let us follow the evidence where it leads and state the conclusion the evidence demands. Something has always existed. This is not faith, it is logic. If there were ever truly nothing, absolute nothing, with no energy, no fields, no laws, no space-time, no quantum vacuum, no mathematical structures, then nothing would exist now. Nothing has no mechanism. Nothing has no capacity. Nothing has no tendency. 0 plus 0 equals 0. And it always equals 0, no matter how many times you add it. But we exist. The universe exists. Stars burn hydrogen into helium at rates of hundreds of millions of tons per second. Galaxies recede at 67.4 kilometers per second per megaparsec. The CMB radiates at 2.725 Kelvin. Atoms hold together. Chemistry operates. Therefore, something has always existed. The universe itself has not always existed. The Big Bang, confirmed by the cosmic microwave background, Penzias and Wilson, 1965, Kobe, 1992, WMAP, 2003, Planck, 2018, the observed expansion, Hubble, 1929, supernova teams, 1998, primordial nucleosynthesis, hydrogen-helium ratio matching Big Bang predictions to high precision, and the Borde-Guth-Vilenkin theorem, which proves that any space-time region with average expansion rate greater than 0 must be past incomplete, establishes a finite past. The universe began approximately 13.8 billion years ago. The BGV theorem deserves explicit treatment. In 2003, Arvind Borde, Alan Guth, and Alexander Vilenkin proved that any universe or any region of a multiverse in which the time-averaged Hubble parameter is positive must have had a beginning. The theorem is model-independent. It does not assume a specific theory of gravity, specific energy conditions, or a specific number of spatial dimensions. It follows from the kinematics of expansion alone. The Hubble law, V equals h sub 0 times d, describes the observed expansion. The Hubble constant is measured at approximately 67.4 kilometers per second per megaparsec by Planck. The expansion rate is positive. The BGV theorem applies. The universe had a beginning. Even eternal inflation, even the multiverse, had a beginning. The escape route is closed. Whatever caused the universe is external to it. Time began with the universe, or, at the very least, our models of time break down at the Planck epoch, approximately 5.39 times 10 to the negative 44 seconds after the origin. Whatever caused the universe is not bound by time. It is eternal, not in the sense of existing for infinite duration within time, but in the sense of existing outside time altogether. It is not bound by the laws of physics, because those laws are among the things that require explanation. The cause is external to the system it created. The evidence demands specific attributes of this cause, attributes deducible from the evidence, not assumed by theology. Power. The cause brought a universe into existence, a universe with a mass-energy content of approximately 10 to the 70 joules, approximately 10 to the 80 particles, spanning approximately 93 billion light-years in diameter, approximately 8.8 times 10 to the 26 meters, approximately 5.5 times 10 to the 23 miles. The power required to instantiate this system from a state external to time and space exceeds anything within the physical universe. Knowledge. The initial conditions of the universe are fine-tuned to a precision of 1 in 10 to the power of 10 to the 123 Penrose. The fine structure constant is approximately 1 over 137, permitting atoms and chemistry within a narrow range. The strong force coupling is calibrated to within 2%, permitting hydrogen and stellar fusion. The cosmological constant is approximately 10 to the negative 122 in Planck units, permitting galaxy formation. The flatness is omega approximately equals 1, requiring initial density fine-tuned to 1 part in 10 to the 60. Each of these values was selected from an enormous space of alternatives. Selection of this precision requires knowledge of the alternatives, knowledge of what each configuration produces, knowledge of which configuration permits stars, atoms, chemistry, and the conditions for complexity. This knowledge is not possessed by unconscious matter. It is an attribute of mind, will. A specific configuration was selected. Selection is an act. Acts require agents. The initial conditions could have been different, overwhelmingly, catastrophically different. The fact that one specific configuration was instantiated, the configuration that permits structure and complexity, implies a choice. Choice requires will. The cause is not a blind, undirected process. It is an agent with knowledge, power, and will. These are the attributes of a creator. Power, knowledge, will, eternality, independence from the created order, including the physical laws, the quantum processes, and the decoherence mechanisms that govern the universe. These attributes are not imposed by theology. They are deduced from the evidence. The chain of causes must terminate. The infinite regress argument, articulated by Aristotle, born 384 BC, died 322 BC, who argued against actual infinities, refined by Thomas Aquinas, born 1225, died 1274, who articulated the first cause argument, and championed in modern form by William Lane Craig, born 1949, through the Kalam cosmological argument, establishes that an infinite chain of dependent causes is logically impossible. If every cause requires a prior cause, stretching backward infinitely, nothing would ever begin, and we would not exist. The fact that we exist proves the chain terminates. Something exists that is itself uncaused, eternal, self-sufficient, independent. This is the uncaused cause, the foundation on which all dependent causes rest. The materialist may respond, perhaps matter or energy is the eternal, uncaused foundation. But the Big Bang, the BGV theorem, and the second law of thermodynamics all establish that matter and energy, as they exist in the physical universe, had a beginning. They have not existed for infinite time. If they had, the second law would have driven the universe to thermodynamic equilibrium, heat death, long ago. The universe is not in equilibrium. Stars shine. Temperature differences persist. Entropy is not at its maximum. Matter and energy require a cause, and the cause must possess the attributes the evidence demands: power, knowledge, will, attributes that unconscious matter does not possess. When I first understood this, that the universe was decided before consciousness, that decoherence operates at 10 to the negative 31 seconds, that every interpretation works without consciousness, that the fine-tuning spans 120 to 123 orders of magnitude, that the BGV theorem closes the escape route of eternal inflation, the materialist framework became untenable. The evidence was not ambiguous. The logic was not optional. The conclusion is not mysterious. It is rational. There is a creator. Let us now assemble the full evidence file. Every datum, every equation, every experiment, every failed escape route. The timeline: 13.8 billion years of cosmic history. At 1 second after the Big Bang, 10 billion degrees Celsius. Within minutes, primordial nucleosynthesis. At 380,000 years, recombination, the CMB released at 3000 Kelvin. At 100 to 200 million years, the first stars. At 9.2 billion years, the Sun and Earth form. At approximately 10.3 billion years, the first life on Earth. At approximately 13.2 billion years, the Cambrian explosion. At approximately 13.7999 billion years, Homo sapiens. Consciousness has existed for 0.002% of cosmic history. For 99.998%, the universe was decided without it. Quantum decoherence, developed by H. Dieter Zeh, 1970s, and Wojciech Zurek, 1980s onward. Environmental interactions destroy quantum coherence at timescales of 10 to the negative 31 seconds for dust grains, 10 to the negative 36 seconds for molecules in air. Ein selection selects pointer states. Quantum Darwinism broadcasts pointer state information, making classical reality objective. The density matrix loses off-diagonal terms through the Lindblad master equation. No consciousness required. Confirmed by quantum computing experiments, Google's Sycamore, 2019, coherence times of approximately 20 microseconds at 15 millikelvin, and IBM's multi-qubit systems. The consciousness interpretation, proposed by Neumann-Wigner, 1961, abandoned by Wigner, 1970s, after Zeh's decoherence work called it solipsism. classified as largely abandoned by the physics community. Niels Bohr rejected the need for consciousness by the 1920s. No experiment has ever shown a difference between outcomes measured by conscious observers and automated detectors. Robert Lanza's biocentrism, 2007, unfalsifiable, no mechanism, no predictions, contradicted by decoherence and by 13.8 billion years of pre-conscious cosmic history. Experiments grounding the argument. Penzias and Wilson, 1965, Bell Labs, CMB at 3 Kelvin. Kobe satellite, NASA, 1989 to 1993, blackbody at 2.725 Kelvin, anisotropies at 1 part in 10 to the 5, Nobel 2006 for Mather and Smoot. WMAP satellite, NASA 2001-2010, age 13.77 GYR, composition 4.9/26.6/68.5%. Planck satellite, ESA 2009-2013, H0 equals 67.4 kilometers per second per megaparsec. Flat geometry to 0.2%. Hubble's expansion observation, 1929. 1998 supernova teams. Accelerating expansion, dark energy. Nobel 2011. Aspects Bell test, 1982. Entanglement confirmed. Nobel 2022. Zeilinger's fullerene interference, 1999. C60 molecules. Decoherence by gas. Tonomura's single electron double slit, 1989. Interference without observer. Davison-Germer electron diffraction, 1927. Wave-particle duality. Quantum teleportation. Bohmian, 1997. LHC Higgs discovery, 2012. 125 GeV. LIGO gravitational waves, 2015. Google Sycamore quantum computing, 2019. Interpretations. None requiring consciousness. Copenhagen. Physical apparatus, Bohr/Heisenberg. Many worlds, no collapse, Everett, 1957. Bohmian mechanics. Deterministic, Bohm, 1952. GRW objective collapse. Girardi/Rimini/Weber, 1986. Penrose gravity collapse, 1989. Consistent histories. Griffiths, 1984. Relational QM, Rovelli, 1996. Transactional, Kramer, 1986. The consciousness interpretation. Abandoned, rejected, refuted. Fine-tuning. Alpha, approximately 1/137. Electromagnetic, permits atoms and chemistry. Strong force, 2% margin for hydrogen/deuterium. Cosmological constant, 10 to the power of -122 in Planck units. Largest theory observation discrepancy in physics. Flatness, omega equals 1. Initial density fine-tuned to 1 in 10 to the power of 60. Penrose's initial conditions, 1 in 10 to the power of 10 to the power of 123. Hawking, very finely adjusted. Davis, as though somebody has fine-tuned. Susskind, anthropic reasoning, not beautiful. The multiverse, zero evidence, unfalsifiable, pushes fine-tuning to multiverse-generating laws. BGV theorem applies. Science will explain it. Faith, not argument. Structural limitation of physics. No equation derives the constants or initial conditions from first principles. The hard problem of consciousness, unsolved by materialism. The equations. Schrödinger equation. I h bar partial psi over partial t equals h hat psi. Deterministic quantum dynamics. Born rule. P equals the absolute value of the inner product of phi over psi squared, measurement probabilities. Heisenberg uncertainty. Delta x delta p greater than or equal to h bar over 2, fundamental limits. Planck-Einstein relation. E equals hf, photon energy. Einstein mass energy. E equals mc squared, mass energy equivalence. Hubble's law. V equals h0d, cosmic expansion. Friedmann equation. A dot over A squared equals 8 pi g over 3 rho, expansion dynamics. Fine structure constant. Alpha equals E squared over 4 pi epsilon 0 h bar c, approximately equals 1 over 137. Each confirmed by experiment. None deriving the constants from first principles. Quantum decoherence. The Schrödinger equation. The Born rule. Einselection. Pointer states. Quantum Darwinism. The measurement problem. The density matrix. The Lindblad equation. The fine structure constant at 1 over 137. The Hubble constant at 67.4 kilometers per second per megaparsec. The CMB at 2.725 Kelvin. The Friedmann equation. The Heisenberg uncertainty principle. Penrose's number. 1 in 10 to the power of 10 to the 123. The BGV theorem. Cosmic inflation. Decoherence timescales at 10 to the negative 31 seconds. 13.8 billion years. 300,000 years of consciousness. A ratio of 46,000 to 1. The universe was already decided before consciousness existed. The evidence is overwhelming. The timeline is conclusive. Decoherence operated for 13.8 billion years without a conscious observer. The physical constants were calibrated in the first moments of the Big Bang, with a precision of 1 in 10 to the power of 10 to the 123 that no random process could produce. Every interpretation of quantum mechanics works without consciousness. Every experiment confirms that physical detectors produce the same results as conscious observers. Every alternative to a creator, consciousness, mysticism, the multiverse, science will explain it, fails under scrutiny. The universe was decided. It was not decided by consciousness. It was not decided by accident. It was not decided by unconscious matter arranging itself into a configuration whose probability of random occurrence transcends comprehension. It was decided by an intelligent, powerful, eternal creator. One who configured reality with knowledge, selected it with will, and brought it into existence with power beyond anything in the physical universe. That is not faith against evidence. That is the conclusion the evidence demands when examined honestly. That conclusion, once reached, changes everything. Good night.